Okay, this is the Miller-Urey experiment that you saw in your homework. Just as a recap, water is heated. The evaporation then goes to be exposed to an electrical spark, which is to simulate lightning. And then it is condensed with a cooler so that there is a residue that collects in the trap, and the water returns back to the system to be considered as the ocean all over again. This is a closed system, and that way it can repeat over and over again with the water until enough residue is accumulated in the trap to make some measurements. You can do this for days, weeks, months. And what they put into the system was water, methane, ammonia, and hydrogen. Now the reason these were selected is because those are the chemicals that would best react to make the molecules necessary for life. It is not because there was any evidence that this is what the early Earth atmosphere was like. They left out oxygen intentionally because oxygen would have trashed the whole system. Oxygen would have caused rust and other unwanted chemicals instead of the amino acids that they were looking for. However, today, nobody believes that this is what the early atmosphere was like. There was a sampling probe that could be entered at the trap, but the trap was not simply in order to collect a measurable amount of the residue. It's because if they allowed it to return to the water tank, it would be completely destroyed by being recycled. So whatever conditions that they're picturing on early Earth, they had to accommodate a sudden change of environment so that the molecules would not be destroyed. Okay, what did they come up with? Miller and Urey found 5 chemicals, biochemicals, but a later group looked at the residue again. Miller passed away in 2007, and in 2008 a publication was released where they had gone back and looked at the chemicals again, and what they found was that there were more than Miller had originally reported. As a matter of fact, there was more than the 20 that naturally occur in the genetic code. Now, if you were just reading this in Wikipedia, you would have thought, oh wow, they got more than necessary in order to produce life. That's not exactly what happened. The 2008 finding came up with 22 molecules, and only 20 are needed for life. Later, an experiment was done in 2010. They came up, adding the two together, they have come up with 32 different ones. The last one didn't come up with 32 on its own, but combining the two, there were 32 different ones. But what really matters is which ones actually are in the molecules for life. Now, if you consider that, then what they came up with was actually 12, which is about 1/3 of the molecules that were actually measured and documented. This is approximately 2/3 of what is needed to have the complete building block set that's used in producing proteins. Now, to have these 20 building blocks, assuming we would someday be able to get all 20 of them using one experiment, and saying that that's producing life, or that that's bringing us towards life, that's like saying we've invented Legos, and therefore the natural result is going to be something like this. By the way, I got this picture of Legos from an article entitled, "How Many Combinations Are Possible Using 6 Lego Bricks?" Would you like to guess how many possibilities there are? Using a computer that ran for a week, this author came up with the number of 915 million. Now, if you can get 915 million possible combinations out of 6 Lego blocks, what do you think the odds are of coming up with a legitimate protein from the possibilities that you have with 20 amino acids? In their book, Stairway to Life, An Origin of Life Reality Check, Ton and Stadler detail 12 different steps that would be necessary in coming up with the organization of matter for life. Now, this doesn't say that it would be alive, that's just saying doing the organization that would be necessary in creating the molecules and so forth. Now, in a previous class, we looked at 2 of these. In this class, we're going to look at just one more. Homochirality of the building blocks. Okay, what is homochirality? Molecules that have 4 connections, mainly based on carbon, that would be all organic molecules, have a possibility of a right or left-handed organization. Let's see what that means. This is an extended part of that same article in Wikipedia. It says, more recent evidence suggests that Earth's original atmosphere might have a composition different from the gas used in the Miller experiment. How about that? But prebiotic experiments continue to produce racemic mixtures of simple to complex compounds under varying conditions. Now, if I were just reading that, without knowing any better, I would think that Yeah, it's too bad that the atmosphere in the jar was not the same as the original atmosphere, but they're still coming up with racemic mixtures, and that's probably a good thing. Not so. Here's a research article. It's published by the Royal Society and is available on the National Center for Biotechnology Information. And it points out that chiral molecules, such as amino acids and sugars, yes, all amino acids and sugars are chiral, are the building blocks of larger molecules, such as proteins and nucleic acids, which are also chiral. Yes, all of them are chiral. Ordinary chemical reactions produce left and right-handed molecules in equal amounts. This is referred to as a racemic mixture. For a gene to encode a protein with a specific shape, the homopolarity of amino acids is required. In other words, they cannot have a racemic mixture. It's got to be purely one chirality or the other. If not, it not only dilutes the molecules that you're looking for, it poisons the products you're trying to produce. It kills any possibility of life. Okay, so what has advanced since then? 1953 was before Elvis Presley and rock and roll. It was before Martin Luther King, Rosa Parks, and the Civil Rights Movement. It was before the first satellite had ever been launched. It was before the Berlin Wall had been built, much less torn down. And it was before the Twin Towers had ever been thought of. In 1953, this is what a computer looked like. This is the IBM 701 electronic data processing machine, known as the defense calculator. It had the amazing capacity of 147,000 bits of information, and you could rent it for $15,000 a month if you ran it for 40 hours. If you wanted to run it for an extra 40 hours during the month, the additional cost would be $20,000. Okay, what's happened in science and technology since then? People have walked on the moon. We have collected material samples from comets, asteroids, and the deepest parts of the ocean. We developed open heart surgery, nanotechnology, and the GPS system. We've measured the size of the universe and photographed black holes. We've sent a satellite through the rings of Saturn and past Pluto, and we now have 3 satellites outside of the solar system. We've cataloged over 4,000 planets around other stars, and your cell phone is 10,000 times more powerful than the IBM 701. In the meantime, what's happened in origin of life research? Will mankind ever be able to create life from non-life? I don't think so, but if it happens, I think it will probably be beyond colonization of Mars and mining asteroids. And when we create life, we will have only one more thing to prove: that the scientists who did it were not intelligent.